All right, so hopefully you've tried these two problems. If you haven't, hit pause, try the two problems. All right, here we go. All right, here we go. So I'm going to take the integral of this. To integrate cosine, I remember that what to what. Take the derivative of what gives me cosine. That's going to be negative sine, right? Nope, that's a lie. Sine gives me cosine, so that wouldn't be negative. My bad. Okay, it should just be positive sine. All right, let's see here. It says positive sine of t from t. Oh, this is ridiculous. Come on, back to pencil. There we go. Of t, there you go, sine of t from 0 to x. And so you should have gotten sine x minus sine of 0, which in fact is just sine x, right? Realizing that we just did this part, the 0 to x derivative, if I take the derivative of this integral, I'm going to go ahead and take the integral first. I get sine of t from 0 to x, same drill. I then get sine of x minus sine of 0. That's going to give me sine of x, which I still take the derivative of. When I take the derivative of that, I'm going to, oh, this should have been plus c. No, it shouldn't have bounced. This becomes cosine of x. All right. Okay. Now notice what happens. If I take the integral and I take the derivative of the same thing, look what happens. Nothing. I end up back where I started, right? Derivative of the integral, they're opposite functions, so you should end up back exactly where you started, right? Okay, so then for some really quick problems, if you look at it, I've got an example here. I got d dx of integral from 0 to x of f of t dt, and that's going to be equal to just f of x, right? The function unchanged. There's some variable switching here. It's not really a big deal. It's all notational issues. Okay, so I'm going to try 81. Integral from negative 2 to 2, and I want you to find the derivative of this. And it's simple. From negative 2 to x, sorry. Negative 2 to x. If I want to find the derivative of this, I'm simply doing derivative of the integral. The answer is going to be x squared minus 2x, and I'm done. Right? Okay, go ahead and do problem 83, and then try the 2 at the bottom, because there is a special thing that happens in those cases. Okay, so we wanted to find the derivative. This is number 83, by the way, which you should have already tried. If you haven't tried already, again, pause it, get it tried. Square root of x to the 4th plus 1 dt. We quickly realize that's just the square root of x to the 4th plus 1. Now you might be asking, wait a second, is there any chance this negative 1 matters? Think about it this way. If I put a negative 1 in, it doesn't matter what the derivative is, I'm going to have a number when I'm done, right? Take the derivative of a number, it goes away, right? So it doesn't matter what the number is, it's just the x up here that carries forward. I'll do that. Okay, so you should have also tried, and if you haven't tried, go ahead and log on. I'll pause it temporarily, then try it. I got t of 3 dt, right? Okay, without using the special rule, so this is without using special rule, so I'm going to have to go do this hard way. T to the 4th over 4 from 0 to x. I get x to the 4th over 4. Then I take the derivative of that, and I get back to x to the 3rd. What was the point? There isn't much point to that one. You could have used the rule. But let's try the next one. D dx, integral from 2 to x squared, t cubed dt. If I use the special, if I don't use a special rule, I would have to go t to the 4th over 4 from 0 to x, put the x in, x to the 4th over 4. Oh, sorry, I got to put the x squared in, so this becomes x to the 8th over 4 minus 0, so that's x to the 8th over 4. Now I take the derivative of this, I'm going to end up with something that I did not expect. Right? And it's like, well, what just happened? I would have expected to have done replacement, right? So if I just replaced it, if I just used the rule we were just using, I would have gotten x to the 6th, right? X to the 2nd to the 3rd power is x to the 6th. Instead, I got 2x to the 7th. So what's the difference? The difference is 2x. And sorry, I need to look back and figure out why I ended up with an extra 2x. So I look back at the function. I integrated t to the third, but when I took the derivative, I had the x squared inside. So it wasn't just an x. So what do? We take the derivative of something that's not quite right. We tack on the chain. What would be the chain of x squared? It would be 2x. So the way you're going to do this problem in the future is you're going to go d dx, integral from 2 to x squared, t to the third dt. What you would do is you would go, aha, I'm going to make that x to the second to the third, but that's not just an x, so I'm going to tack on the chain. What's the chain? With the derivative of x squared is going to be 2x. So this is going to give me 2x to the seventh, and this is the way we do it the fast way. All right? So we do the fast way. Okay, so the problems in the back should be easy peasy lemon squeezy. Go ahead and blow through them all, and then go ahead and get assignment 7-6, and that's going to take a little more explanation, and I'll see you on the next video.